Hi, my name is Jackson Marusars, and I'm a product manager here at NVIDIA. I'm excited to be at the ARM Dev Summit, talking about how HPC users doing CUDA development on ARM can take advantage of the Nsight developer tools we're working on in my team. Really quickly, I want to give a brief overview of the developer tools we offer. We have a set of debuggers to help you understand your CUDA code and your CPU code. This includes CUDA GDB and our newly released Nsight Visual Studio Code Edition. Additionally, we have performance profilers in Nsight Systems, Nsight Compute, and some SDK and trace type tools with CUDA and our NVIDIA tools extension NVTX. For correctness checking, we have our Compute Sanitizer. This is going to help you find things like memory leaks, uninitialized memory accesses, common correctness issues that are difficult to detect. And lastly, we have our IDE integrations. Nsight Eclipse Edition for Eclipse users, and the recently released Nsight Visual Studio Code Edition for people that want to do CUDA programming using the Visual Studio Code interface. First, let's talk about our compute debuggers. CUDA GDB is our classic Linux backend for debugging both GPU code running on the device as well as CPU code on the host. It supports things like breakpoints, stepping through the code, understanding inline functions, variable inspection, all the things you would expect from a common debugger. If you're looking for more IDE integration of debuggers, that's where our Nsight Visual Studio Code Edition comes in. This was just released in the last year or so, and it's a new IDE integration for Visual Studio Code. With Visual Studio Code, you can remotely target SBSA platforms that have CUDA devices to do debugging of the code running on that remote machine from your Windows or Linux host. To give a little bit more detail on CUDA GDB, this is a command line debugger, and it's also the backend for many of our IDEs running on Linux doing CUDA debugging. It allows you to do unified CPU and GPU CUDA debugging all in the same instance. It supports the CUDA C language as well as the native language you're debugging, and has support for the assembly known as SAS for CUDA. You can see the detailed debugging information as you step through these lines of code or assembly. It's built on GDB, so users that are familiar with that interface will be quickly familiar with CUDA GDB as well. Most of the same CLI commands will work on CUDA GDB just like they would on GDB running on the host. Things like breakpoints, stepping through the code, inspecting variables can all be done from the CLI or in the GUIs if you're using CUDA GDB as the backend. Now let's look at some more details on Nsight Visual Studio Code Edition. If you're a user of Nsight Visual Studio Code Edition, you'll know that there's multiple ways to add extensions. We have our own extension for CUDA debugging, and you can install it in two different ways. First, you can use the built-in Visual Studio Code Marketplace, which is what most people use. If you just search for CUDA, you'll see the extension right there, and you can easily install it into your environment. Additionally, you do have the option to download the V6 file from the Visual Studio Code Marketplace and manually install it. If you're managing labs or groups of machines, this may be the most straightforward way, depending on the environment you have set up. Visual Studio Code is a very popular environment for both development and debugging. With this new CUDA integration, it allows users that are doing CUDA development that love to use Visual Studio Code to find everything in one place. If you're familiar with debugging from an IDE, then a lot of what you see here should look pretty familiar. What we've done is we've integrated breakpoints and debugging into Visual Studio Code. Now, when you hit a breakpoint in the GPU device code, you'll get an interface just like you would with other IDE debuggers. You can inspect things like variables, you can look at the CPU and GPU registers at any given time, and there's a watch list for specific variables that you're interested in monitoring throughout the debugging session. On the lower left here, we can see the session status that we're debugging with CUDA GDB. In the center, you can see that there's actually a built-in debug console. This debug console allows you to run CUDA GDB commands directly, so if you're very familiar with CLI debugging, you can still do the same types of things within this integration. On the right side, we're looking at the call stack, which is obviously very important from a debugging standpoint. Understanding how you arrived at the specific code location you're currently inspecting is very important for both CPU and GPU debugging. In the lower right, we have something called the CUDA focus. Because GPUs are highly parallel, you need to understand specifically what SM within the GPU, what warp within the SM, and what lane of the warp you're inspecting. The variable values may change depending on your CUDA focus, and if there's a specific bug you're trying to track down, it may only occur in the specific focus as well. So it's important to know where you're looking at any given time during the debugging session. Now let's take a couple of minutes to look at the correctness checker we have available for CUDA developers. Compute Sanitizer is the command line tool available for doing correctness checking of CUDA applications. It can be used to automatically scan for various types of bugs and memory issues on a CUDA kernel dynamically as it runs. It supports CUDA correctness checking on many platforms, including SBSA platforms. Compute Sanitizer is built of several subtools that each have a different function. The memcheck tool is used to detect things like memory access errors and memory leaks, which can obviously cause performance and correctness issues in applications. The racecheck tool is designed to find data races on shared memory where you have insufficient synchronization or unprotected variable accesses. The initcheck tool searches for uninitialized device global memory accesses, where you may be reading garbage because the values have not been written before they're read by the application. And lastly, the synccheck tool is designed to monitor the thread synchronization and detect hazards if it's done improperly. The nice thing about Compute Sanitizer is that it can easily be added to scripts for automatic testing. You can have Compute Sanitizer run as part of your test suite and provide a report without needing the developer sitting in front of the machine debugging the code manually. Next, let's talk about the performance profiling tools we have. These are our Nsight tools, and we have a diagram here of the common workflows developers interact with them through. At the top, we have Nsight Systems, which is our platform profiling tool. This one's going to give you information about both the CPU and GPU. It's going to do tracing of API calls and give you a timeline to help you understand what's going on in the overall platform performance. For this talk, we'll talk mostly about Nsight Systems and Nsight Compute, which is on the left side. Nsight Compute is our kernel profiler. Once you've identified a CUDA kernel of interest, you can use Nsight Compute to do a deep dive on that kernel and find out exactly what the performance bottlenecks are and understand where they're occurring, and it'll give you some advice about how to fix those. If you're a graphics programmer, you'd use Nsight Graphics to dive deeper into your graphics workloads. We won't talk about Nsight Graphics today, but if that's something you're interested in, be aware that Nsight Graphics is available. Let's look more into Nsight Systems. Nsight Systems is our high-level platform profiler. This one's going to give you system-wide performance data for both your CPU and your GPU and how they're interacting. This will help you identify the opportunities for performance tuning for both your algorithm and at the low level. It supports multiple processes, so you get an overview of everything that's interacting. It helps you locate the optimization opportunities with a really powerful GUI. You visualize millions of trace events and hardware events on a GUI timeline, which lets you correlate the various activities between the CPU, the GPU, the threads, and all of the different things that are going on the platform. It also helps you identify gaps of unused CPU and GPU time when the hardware is sitting idle. Obviously, these gaps are indications of performance that could be left on the table. You can use Nsight Systems to balance your workloads across the multiple resources that you have available. Your algorithms may perform better on the CPU for various pieces or the GPU for other highly parallel pieces, and understanding how that utilization is balanced is very important. Seeing things like the thread states, the GPU streams you're using, all of the kernels that are running, when they're running, and how they're interacting, memory transfers between the host and device. All of these things in one view give you a detailed understanding of what's going on the platform. It's available both the command line and a standalone GUI, and has integration into IDEs. Obviously, we're supporting both Linux and Windows with a Mac host, and you can profile Arm SBSA targets with Nsight Systems. As you can see here, there's a lot of information available on the Nsight Systems timeline. You can see on the left side various swim lanes for things like processes and threads, the APIs from CUDA or OpenGL, or a bunch of other APIs available as well. So tracing when those APIs are called allows you to correlate them with performance data. A lot of libraries are supported as well. Things like cuDNN and cuBLAS can be traced with Nsight Systems. Looking a little bit lower, we see the information about what's going on the GPU, the kernel and memory transfer activities, and if you have multiple GPUs, you'll even see all of those on the timeline as well. You can identify issues like thread and core migration on the CPU, things hopping around that could be impacting performance, and understanding what state your threads are in so you can see if there's work available to be scheduled or if you're sitting in an idle state with nothing available to run. As you can see, that last slide was very crowded because there's a lot of information in Nsight systems. The great thing about the GUI is it's extremely interactive. You can zoom and filter on any area of interest, getting down to the millisecond and smaller granularities to see exactly where things are occurring. Where are my CUDA calls? Where are my other API calls that I'm tracing? What's going on the CPU while this is happening in the GPU? All of those things on the same timeline give you detailed information about the entire platform and help you target the specific area where performance issues could be occurring. Now let's look at some of the new features we've introduced in Nsight systems. One request that we've had for a long time is understanding the CPU and GPU page faults from CUDA Unified Memory. Unified Memory is a great resource for making CUDA programming easy, but it is important to understand how it could impact your performance. Obviously, paging in CPUs is a big deal, and it's the same for GPUs as well. Paging can also occur when you're using unified memory. Finding those page faults and understanding how long they're taking and how they're impacting performance is now available in Nsight systems. Another recent addition is GPU metric sampling. Whereas before, Nsight systems was mostly a trace tool showing you API calls on a timeline, now we're also collecting some hardware metrics from the GPUs. These will help you understand things like if your GPU is full. Do you have large enough grids to take advantage of the whole device? Is your instruction rate low? Are the issues coming from the front end not sufficient enough to fill up the device? Could you be I/O bound? Are you using the tensor cores, which are extremely efficient processing units on the GPU? If you have an application that you're expecting to take advantage of the tensor cores, it's very difficult to understand how well you're doing that without some sort of visualization. Now we have that in Nsight systems. You can see GPU direct RDMA and storage transfers, and these GPU metrics are system-wide. You don't need a specific app to be profiled, but you might need some specific permissions to gain access to them. There's a default frequency for collecting these metrics as it's a statistical sampling, and this can be decreased or increased depending on the GPU, the workload, and the overhead you're seeing. Some of the most important metrics we have are SM utilization metrics, telling you how many SMs are active, the instructions they're executing, how active are the tensor cores, and what's your occupancy. And additionally, we have metrics around I/O for things like PCIe, NVLink, and DRAM. Next, let's look at Nsight Compute, the detailed CUDA kernel profiler. Nsight Compute is the tool for highly detailed profiling of CUDA kernels. It has both an interactive and non-interactive profiling mode. The interactive profiling mode allows you to step through CUDA APIs to target the exact area of interest for your profile. And a non-interactive mode is kind of a set it and forget it. You can kick off the profile all of the CUDA kernels you're interested in, and come back and see the results. There's built-in rules expertise, a customizable interface, and it's available from the command line, a standalone GUI, integrated into IDEs, and supports remote targets, including SBSA targets. When you run an Nsight Compute profile, the data is going to be presented in various sections, each of those representing some section of performance information. The interface is fully customizable, so you can choose what data to collect and how to display it as well. Getting started, all of the defaults are very powerful, and many users never need to do any customization. But as you become a more powerful user of Nsight Compute, understand that you can do whatever you want with it as you learn how to customize and present the data. I think the most powerful aspect of Nsight Compute is the built-in expertise for guided analysis and optimization. After Nsight Compute collects a bunch of performance data, it runs an analysis and compares them to built-in thresholds to understand what bottlenecks may be occurring, what other performance issues you could be running into, and provides some key information about how you could fix those issues. In the memory workload analysis chart, we have a visual representation of the memory hierarchy between the device and the system. You can see how much memory is being transferred between the various levels, as well as the data rates. The metrics presented in the tables give you an idea of the peak performance for each of those buses and also what kind of performance ratios you're seeing between reads, writes, and percentage of peak. There's also a source correlation view. If you have the source code and debug information available for the device code that you were profiling, you can see it in Nsight Compute at both the source level, the PTX level, and the SAS that was generated by the compiler. And it's all correlated. So click on a line in your source code, and Nsight Compute will highlight the associated assembly that was generated by the compiler. The metrics aren't just available on the line of source code, also available at the assembly level. And the metrics can be calculated per line of code, so you understand exactly which statement in your application is impacting performance. Next, let's talk about a couple of the new features in Nsight Compute. One new feature is the addition of roofline analysis. Roofline analysis helps you find hardware limitations for your CUDA kernels from the memory hierarchy. There's a lot to get into to understand roofline analysis, but just giving a brief overview, what you're doing is you're graphing the performance versus the arithmetic intensity of a kernel. Essentially, how often are you accessing memory for every calculation that you do? Based on this information and some known information about the platform, Nsight Compute can calculate whether your kernel is bumping up against hardware limitations from the specific physical limitations of the chip you're running on, or whether there's more room for improvement in the algorithm before you bump into one of these roofs. The built-in roofs represent the system hardware limitations, and the visual representation lets you see how close you're getting to those. The new profile series feature, also known as a what-if analysis, does some automatic performance analysis of some configurable parameters for CUDA kernels. You can set things like the number of registers per thread, the shared memory size per block, and the shared memory configuration for the device. Then the profile series analysis will automatically run through the permutations of those various settings to find the specific configuration that gives the best performance. Historically, people would do this by hand using spreadsheets and calculating the permutations to try, but now it's built directly into Nsight Compute. We also just added something known as the register dependency analysis. This is a visualization in the source view to help you see the dependencies for register reads and writes. Using this information, you can identify long dependency chains in the application, which may be causing bottlenecks or performance issues. It also helps you detect inefficient register usage, where you may be able to improve your performance by more efficiently utilizing the registers available on the device. That was just a really quick overview of the tools we have available for users in the Arm plus CUDA HPC ecosystem. All of these tools are free and they're packaged in the CUDA toolkit. The most recent versions are also available at the Download Center. Some of the features I mentioned in Nsight systems can be found in the latest versions available at the link here. We also have online support via our forums. We also have more information online, including quick start guides and kernel profiling guides for Nsight tools. Thanks for watching. I hope you got something out of this presentation. I encourage you to go check out the CUDA tools we have. They're freely available for download. Let us know how we're doing. We're very reactive to feedback, and we appreciate everyone that helps us make the tools better. Thanks again.